All right, moving on here. This is Kinesiology 230, Chapter 23. We're still talking about resistance training for athletes and our clients who are athletes. And this presentation jumps into resistance and repetition in terms of training load. And this is found on page 616 of our book. Here's where we are in the process. We've already gone through factors. Now this one's all about training load. So training load is the amount of weight to be used. It kind of makes sense, right? End of presentation. But when we talk training load, it can be quantified as a percentage of one rep max. And it's kind of an objective measure in terms of how strong a person is. And the volume itself is the number of repetitions that you do something. I'm almost certain we've talked about this before. Total volume is the number of repetitions performed for a specific workout. So you pick up a bar, boom, it's 135. You bench it 10 times, that's 10 reps. That's your volume for that one set. But if you do 3 sets of 10, you'd have 30 total reps. That's your total volume. Load is the amount of weight to be used. So in that example, it's 135 pounds on the bar. So you got 135 at 3 sets of 10. So we have total volume load, which is the reps times the sets times the load. So it takes a combination of things here. So you have the number of reps that are performed within each set, 3 sets of 10, that's 30 repetitions. We're doing 135, so then you take your 135 and multiply it by 30, and that'll give you the amount. So when you look at this, if you just want to look at it in terms of total volume load, when you calculate out work, right, we've already talked about work versus power and pushing the boulder versus pushing the boulder for time. But when you look at loading parameters for resistance training, when you look at total volume load, it's a way to use and a way to evaluate your programming. But the thing is, when you start talking about programming and you're doing 3 sets of 10 for me versus 3 sets of 10 for you, you might not be pushing 135, you might be pushing 235, and I'll be pushing 135. So our total volume load is going to be different. When you're programming out for an entire group of people, a team of 100 football players or 500 athletes altogether, when you're calculating out that total volume load, if you make it total volume load on a base of percentage, that's a different story. So what you can do is you can do 3 sets of 10 at 70% instead of 70 pounds, which in our parlance, percents are pounds, right? It's just a percentage of your maximum weight anyways. But in terms of comparing apples to apples and really trying to get programming down to that type of common denominator, 3 sets of 10 is 30 reps, and 30 reps at 70%, you can go 0.7 if you so choose. I just did by times 70, gives us 2,100 total volume percent load. And when you do 3 sets of 10 at 65%, that'd be 1,950 total volume percent load. You can make the argument in terms of just multiplying your 70% times your max and coming up with that number. But I will tell you, when you're trying to program it out, if you have 20 offensive linemen, your 20 offensive linemen may have 20 different maxes or 15 different maxes. So if you do this on a percent basis, it makes it easier to kind of equal the playing field when you actually do your programming. So on a percent basis, excuse me, when you do this on the front end, it helps you to kind of map out your rep and set schemes on the front end and not just write down what you did. Okay, so I want you to do 3 sets of 10. Well, I did my first set at 135, and then I felt pretty good, so I went to 140, and I felt pretty good, so I kept it at 140. No, no, no. If you're coaching this stuff, you're coding this in and programming in 3 sets of 10 at 70%. Here's the weight you're going to do. Now you tell me how you did based off of what was written out for you in the program. So I have to just stress this though. It becomes a little bit of a brain bender when we start talking total volume percent load for some people, because when you get into the percentages and you start talking load and the rep ranges and the total volume, it should be an inverse relationship. But when you do total volume load and you have lower rep parameters, for download weeks, etc., it can be challenging to wrap yourself around what is and what is not a hard workout. Let me get this guy out of the way here. So in the book, And I point you to this because I do the math a little bit differently. I do that 0.03 coefficient per rep. The book notes when you do a workout and say you do a set of 10, you're going to be at about 75%. I would contest that 75% is a little bit high, but I'm not the one who writes the test for the NSCA. All right, so you have percentage of a 1 rep max relationship. So as you're working out and you're going through your workout, what you have is a repetition relationship that happens with the percentage that you're using of a 1 rep max. And it kind of makes sense. If you can only do 1 repetition, you're probably at 100% of your 1 rep max. If you can do 10 repetitions, you're at right around 75%. Now the book, and I have to give you a fair warning on this, in one of the test questions, it will require you to calculate out what percentage you're actually doing. And while the book recommends 75%, it'll calculate out at like 73.5% or some quirky number. So you have to look at it in terms of like what's close. And they make it apparent where it's like, it's darn close to the 75 and the other three answers are like 90%, 80%, and 55%. So you know that your 75 is close enough to throw a horseshoe and get close to, but it's not the exact number. So don't freak out on that when you see that on the test, but that's just how they wrote it. So the repetition maximum itself is you would have your athletes perform maybe a test out and you're asking them to do a 4 repetition max. And you're going to have them do 4 reps, and that would be at approximately 90% of their 1 rep max. And where this becomes a little bit of a brain bender, I'll do the math for it later on, is what if you do 5 reps, right? Or what if you actually do, instead of 135, you do 140 for your 4 reps? Well, there's some math to be had there, and the math substantiates that your person got stronger. So they talk about repetition maximum. I talk about the 1 repetition maximum, and then I talk about a rep target. And it's a repetition range or repetition number that you're going for. All right, how many are you going for? Person lays down on the bench press. I'm going for 6 on this set. Okay, 1, 2, 3, 4, 5, 6. They bang it out. Perfect. You'll also have people where you'll ask them, hey, how many are you going for in this set? Well, somewhere between 4 and 6. That's going to be an RM target zone. That's different than the more precise and specific target rep number itself. So as a person who has spotted a ton of people in my life, I've heard this, and as someone who has done programming, I've used this, and I've used these two down here as well, and so will you when you get into working more and more with people. Let me get myself out of the way here. Now, the point I want to make with this is, I noted I use a 0.03 to calculate out, but it ends up being almost logarithmic, right? So the closer you get to 100%, the tighter that coefficient gets. And by that, I mean, if I do a set of 4 and I go 0.03 times 4, that gives me a number, a coefficient. It's 0.12. And I use that number, and I'm not going to stress too much on this slide to go over this, but I use that number to help me calculate out that my workload should be at about 88%. 1 minus coefficient, in that case is 0.12, gives us our 0.88 if you want to just pause me and do the math on that. So it's 0.88 times your max. But there's another part of this. What if you go to work with your client, they lay down on a bench press and they do a set of 7 and they ask you, well, I just did a set of 7 at 135. What's my max? What's my actual max on that? Mathematically, you can calculate that out as long as you know how many reps correlate to what percentage, and you can do the math backwards to get to what their actual 1 rep max is. So it's a useful tool, and anybody told you you're not going to be using algebra, when you got older, they're lying to you if you're in this industry. All right, so they list several different bullet points, and they talk about the relationship between 1 rep max and a number of repetitions that can be performed, but they suggest the relationship is not as robust as once thought. And they talk about percentage of 1 rep max being a tool. And I agree with that, and I use it in my training and programming. I will also contend that training status absolutely influences that. I've had athletes who have a higher training age than other athletes, and they're clearly better coordinated at firing their muscle better. I've also had athletes who had a higher chronological age, and they also were a little bit more coordinated, than their peers. But they talk about the number of repetitions performed at a specific percent 1 RM is related only to a single set and not to multiple sets. Now, from a programming standpoint, and I wrote it earlier, 3 sets of 10 at 70%. In reality, what happens is this: when you get more adept at programming and you have a tighter understanding of your athlete's maximum. Well, if my athlete has a 200-pound max on bench press, and we've tested that out, and we know that number to be true, 200 pounds, if I ask them to do 70% for sets of 10, well, 70% of 200 is 140 pounds. But I will tell you this: on their first set of 10, they can get that 140 pounds. On the second set of 10, they can get their 140 pounds, but it'll be tough on the last two. And this is if it's programmed correctly. If you try to do a third set at 140 pounds, they'll probably get 8 and they'll cap out right at 8, and that's going to be about it. Because of the fatigue factor, and we've talked about the lactate and everything else that happens in terms of muscular fatigue earlier, but what ends up happening is you have, because of the byproducts associated with muscle contraction, you have a lower contractile ability on that last set just because of fatigue. So in essence, what you have to do from a programming standpoint, you might do 3 sets of 10, but your average is not 70% straight across the board. More accurately, when you do your 3 work sets, after a little warm up on the front end, you would have 1 set at 70%, a second set at 70%, and a third set perhaps at 65, maybe to 68%. So instead of doing 145, they're doing 135. You reduce the workload on them a little bit so they can actually have positive reps. So there's a correlation there, and you get better at being able to work back and forth, with the math. Now, I will say this: pay attention to number 7. Whether it's a core or assistance exercise, placing an exercise towards the end of the workout results in a decrease in the number of repetitions. They'll talk about the squat, the bench press, and this, and then they'll put bicep curls at the end. And they'll want you to answer bicep curls at the end is the one that's going to have the lowest number of repetitions. Guidelines for assessing load. All right, so you talk about how do you assess and calculate 1 rep max? Do you use a percent of client body weight? Is it repetition testing? And I will tell you, 1 RMs are challenging to implement, and they're something you wouldn't normally do unless you've prepped your athletes for that. And we'll talk a little bit later on in the macro cycle that I put together for a soccer team. And we'll talk about like the test out weeks and why I did it the way I did it and how we ended up going through power peaking. And we actually didn't even do test outs until right before the season starts. I digress. But what they're looking for in the book here is the 1 rep max. It's minimal risk, etc., which is fine, but you have to be trained for it. And the other part of it is it's considered the gold standard for muscular strength assessment. So just remember that. You can estimate it just kind of like by having a nice guesstimate in terms of what their 1 rep max would be. And you go with lower repetition. So if you're in the 6 to 10 range, that's going to be closer to the 1. There's a question that asks you in specific what's going to be more accurate, 6 to 10 or 20 reps. It's going to be the lower rep number. And then when we get into here, there's a couple different maximum prediction equations. You can pause me here and look at these. There's also an Epley formula. It's pretty well known. I use 0.03 per rep just to keep it simple. They give you some nice tables here from which to work from. So for example, if you do 8 reps, you should be at percent denoted here. And if you are able to do 208 for 8 reps, then your max is 260 pounds. That's how you read that scale. So with this is a beast to go over. And I'm going to pause this right here, and I'll put this into another presentation for you here in a second. All right, hold on.